Hi guys, so today I will continue with chapter 9, which is random variable. So in this video I will go through all the subtopics of chapter 9, which is 9.1 introduction to random variables, 9.2 discrete random variables, and the last subtopic 9.3 continuous random variable. So I will go through with chapter 9.1 first. So what is variable? So variable is a characteristic or attribute that can assume different values. Whereas letters of alphabets such as X, Y, or Z are used to represent the variables. So I provide two examples. The first example is if a dice is rolled, a letter such as X can be used to represent the outcomes. So the value X can be 1 or 2 or 3 or 4 or 5 or 6, corresponding to the outcomes of rolling a single dice. So as you know, you roll a dice. It has six faces, so it can be one, can be two, can be three like that. Or I just simply draw it, or four, or five, or six. So if you roll the dice one time, so it will come out one, or two, or three, or four, or five, or six. So the letter X can be represent these outcomes. So later you will know how it present. And the second example is if two coins are tossed, a letter Y can be used to represent the number of heads. Like if I throw it, it come out the head. Okay, sorry, my drawing. So if the like this number it comes out two times. So I throw first times. If I get head, so one. So if second times I get tail, so the number of heads will be zero. So the total number of heads so I get is 1 plus 0 equals to 1. Also same if like I toss the coin and get the head two times, so my outcome will be 2. And inversely, if I toss the coin twice and I get both tail, so I will get my outcome will be 0 because there are two tail. Okay. So since the variables are associated with probability, they are called random variables. Yeah, this got related with the probability. Okay. So what is the random variable? So it is a function that assigns a numerical value to each simple event of a sample. Usually, random variables are denoted by capital letters such as big X and big Y, and their corresponding small letters X and Y are used to represent particular value of the random variable. Okay, so I prepared some questions so you can know what the random variable means. Okay, question 1. State which of the following are discrete or continuous random variable. So A, the number of copies of the New Straits Times sold each month. The New Straits Times is the newspaper. Yeah. So let's you can just simply note that the maybe none of these newspapers sold or got 5 or 10. So it got like a particular value, so it is discrete. The amount of ink used in painting, so we cannot count the amount of ink, right? So maybe like in an interval, so it is continuous. The actual number of ounces of laundry detergent in a 1 gallon bottle. Okay, so this quite big number, so we can just use like the interval, so it's continuous. Last, the number of patients what are admitted per week in a particular hospital. So number of patient per week, so can be like this week got 75 or 175 or something. You can just straight away know the number, so it's discrete. Okay, a fair dice a fair die is thrown, and the number of the die is a random variable x. So write the probability distribution function and build the table and sketch the function. Okay. So A, write the probability. So the event will be the large X. Just now I said the event will be the large X. This is the event. And the small x will be the outcomes, the possible outcomes. So a die is a cube. It has 6 faces. So it can be 1, 2, 3, 4, 5, and 6. Based on what the number, like the number two face upwards, so the outcome will be 2. If the like number 3 face upwards, so number 3 will be the outcome. Okay, build the probability distribution table. So just simple, you build one x, sorry, yeah, you just build the x at the up, and the probability will be at the down. So it can be occur 1 per 6 times. And last, sketch the probability distribution function. This you got learn this at secondary school, so it's familiar to you maybe. So because all the possible outcomes will be 1 per 6, so all the same length. Yeah. So I go to the discrete random variable. So a discrete random variable assumes the values that can be counted. Yeah, just now I said the number of the newsstrike times. So each month like this, yeah, you can just know I got 5 newspapers sold, 75 newspapers sold, 175 papers sold, newspapers sold, like this. So in other words, the constitutive values of a discrete random variables are separated by a certain gaps. A random variable that assumes countable values is called a discrete random variable. Like just now, this random variable is considered the discrete random variable because it's at the certain gap. So the examples are the number of cars sold at a dealership during a given month, the number of employees working at a company, and last, the number of complaints received at the office of an airline on a given day. This can be counted, so they are discrete. The probability distribution. The list of all the possible values of random variable x with their corresponding probabilities is known as discrete probability distribution. So suppose x1, x2 to the last x, I let it k, are the values of a distribution. Okay, I write this drv as discrete random variable because the name is quite long, so I just simplify it as drv. So just take note lah. And later the continuous random variable I will simplify it as crv. So the suppose if like you got k values and the x1, x2 till the last value, xk are the values of a discrete random variable x which are associated with the corresponding probabilities. P equals big X equal x1 like this until the P bracket large X equals to the last value, the last probability value. And if I remember this, so if the sum of this probability equals to 1, then x is known as a discrete random variable. Like just now, you can see 1 per 6 plus 1 per 6, 1 per 6, this 1 per 6 times 6 times, so equals to 1, so it is a discrete random variable. So if the large x is a discrete random variable, then the probability will between, not between, like from their interval is from 0 to 1. So same as the probability in chapter 8, this 0 is the impossible outcome and 1 is the like possible outcome, the most possible, 100% possible. And the total sum, just now I said, the total sum of the probability will be 1. It's same concept as the chapter 8 probability. The probability distribution can be presented in the form of table, function, and graph. So later I will show question. So you can know how to produce in the form of table, function, and graph lah. So given a discrete random variable x, its mode is the value of x that is most likely to occur. Consequently, the mode is equal to the value of x at which the probability distribution function reach a maximum. So later I will show you. Cumulative distribution function. So the corresponding cumulative probabilities are obtained by summing out the probability up to a particular value. The resulting function is known as the cumulative distribution function. So if x is a discrete random variable with probability distribution function for x equals to x1, x2 to the last x, so then the cumulative distribution of x denoted by fx, large fx, is given by like sum out the first to the last. So the median is the value when the probability is equal, the probability is the sum of the probability is equal to 0.5 or fm equals to 0.5. So in general, px equals to a, like fa minus f a minus 1. So you can see px equals 3. So like this f3 minus f2. Let me show an example so you can remember. So if I want to find px equals to 3, like, okay, let me show the cumulative first. So 1 over 6, this is f1, f2, 1 over 6 plus 1 over 6, 2 over 6. So f3, 3 over 6. f4, 4 over 6. f5, at all 5 over 6. So the last f6 will be 6 over 6, or just write 1. So usually we just write 1. Okay. So I will try to show. Px equal to 3, like f3 minus f2. Like 3 over 6 minus 2 over 6. So I will get 1 over 6 is this f3. Px larger than a, so it will equals to 1 minus px smaller or equal to a, or just 1 minus fa. So px larger than 3, so like 1 minus f3. So I want to find p larger than x3. 1 minus 1 minus f3. f3 equals to 3 over 6. So you'll get 3 over 6. So simplify as 1 over 2. So I will get px larger than 3. So I will get this 3. 1 over 6, 1 over 6, 1 over 6. I'll get this value. Px equals to 4 plus px equals to 5 plus px equal to 6. So it is larger and equal to a, like this. So just 1 minus this a minus 1. So if like 3, so 1 minus f per 2. 1 minus f2. So I will get 4 per 6. Px larger than 3. So it includes this x equals to 3 plus 4 plus 5 plus 6. This 1 per 6 plus 1 per 6 was 1 per 6 plus 1 per 6. Okay, if series is smaller, px smaller than a, so it not includes a, so just a minus 1. Yes, you can know if got smaller than equal, so it got include this a, so just px smaller equal to 3, so equal to f3. This simple. P A X B. So it does not include this A and does not include this P. Like this 2 X 5. Does not include this 2, does not include this 5. So just P X equal to 3 plus P X equal to 4, or just use F4 minus F2. If got this smaller, so it got include this A but not include this B. So like this got include this 2. So x equals to 2 plus x equal to 3 plus x equal to 4. So just f4 minus f1 because got include these 2. So no need to minus away these 2. But if this does not include this a but got include the b, like this case does not include 2 but got include this 5. So the outcomes got include is 3, 4, 5. So just use f equal to 5 minus f equal to 2. No need to minus 3. Because the 3 is got include this probability. And last, if A got include, B got include. So like this 2 got include, 5 got include. So you need to, the probability you need to consider is the outcome with 2, 3, 4, and 5. So just f5 minus f1. Do not minus away this f2 because 2 got include in this probability. So later I got prepare one big question what big question that could includes all these syllabus. All the things will come out. And the last is the expectation of x. Expectation of the expected value of a random variable I can be discrete or continuous. So it's the mean of x. Mu is denoted by mu or ex. Usually denoted by ex lah. The mu is in the chapter 10. Usually you'll come out in chapter 10. So if x is a discrete random variable with the probability distribution function, then so it will be like x times the total sum of this x times the probability. That is, let me show. You can see x times this. 1, 1 per 6 plus 2, 2 per 6 plus 3, 1 per 6 plus 3, 1 per 6 plus until 6, 1 per 6. So the sum will be the mean. So the expectation of any function of x is given by this, with the function times the probability. So later we will note, in particular when gx equals to x squared, so it will times this this is x, right? This becomes x squared times this probability. Like this, 1 square per 1 square times 1 per 6 plus 2 square times 1 per 6 plus 3 square times 1 per 6, like this, until 6 square. Sorry. 6 square, 4 square, 5 square, 6 square. So this is the ex square. So important properties. This is true for both DRV and CRV. So later continuous random variable, I will not talk it again. So if like E3, EA equals to A is a constant like this E3, so will be 3. So EAX, E3X, so it will be 3EX. The EX is a value lah. So E3X plus 2, so it will be 3EX, either what value, 3EX plus 2. Remember to plus these 2. Last is the variance. So variance of a discrete random variable x is denoted by var x, or this sigma 2, a sigma square, and is defined as var x equals to ex minus mu square, where mu equals to ex. So it's simplified as this large x equals to mu square. So I factorize it. So use the properties just now. So become ex square. The 2 mu is the value, so 2 mu ex plus this mu square. So mu square same as ex, this the mean square. So the mu, just now I said mu, so mu with ex, they are same, so it become ex square. So negative 2 plus 1, so become negative 1. This ex square remain. So the variance x, the find, okay. It's not sharp. Maybe I use this. This variance x equals to, sorry, e ex square minus mean square. Here. The standard deviation of the random variable, either in discrete or continuous, just square root it. So the variance is always positive, so if you find it's negative, so you will be wrong. So the properties is true for both discrete and continuous, so later I also not talk it again in continuous. So if like there's no var 3, var a equals 0, so like var 3 nothing, so it will be 0. You can just recall back the properties, this the dispersion of data. Measure dispersion, you can recall back the properties, so if like add on something like this, add on b will not affect the value of this variable. So it will be affected by adding like multiplying or dividing only. If plus or minus will not affect. So if in conclusion, var 3x, so will be 3 square var x, so will be same as 9 var x. And this last, for example, var 3x plus 2, so these two, in the measure of dispersion, these two will be not be affected, so the 2 can be ignored. Just take 3 square var x, also same as 9 var x. This var x will be the value. Yeah. So this is all for the discrete random variable. So let's go to the question. This is the big question as it includes all of the things we learn. The discrete random variable acts as a probability function. So find the value of A. Yeah, you got 11 things. So first we look at A first. So A just simple. As you know that sum of the probability will be 1. So you just sum all up. The A I just take out because they are the same. You can just invert 5 minus 0, 5. 5 minus 1, 4. 5 minus 2, 3. 5 minus 3, 2. 5 minus 4, 1. So equals to 1. So 5 plus 4 plus 3 plus 2 plus 1, so equal to 15. 15a equals to 1. So a equals to 1 over 15. Yeah. So sketch the it doesn't call us to sketch, but for easy to see, we sketch the probability distribution table. So just add this. So this A as 1 per 15, 1 per 15, 5 minus x, and just sub all this 0, 1, 2, 3, 4 inside. So I will get 5 per 15, 4 per 15, 3 per 15, 2 per 15, and 1 per 15. You can simplify it also, but for me, I just let it as this form 5 or 15 for easier me to look for later. So P, the probability more than 1 and less or equal to 4. So the probability you need to find does not include this one, but got include this 4. So you need to find 2, 3, 4. So you need to find Px equals to 2, x equals to 3, and x equals to 4. So 3 per 15 plus 2 per 15, 1 per 15. So I will get 6 per 15, or you can simplify it as 2 per 5. C is the mode. Yeah, that's why I want to construct this table. For easier to me, C which has the largest probability. So as you can see, the mode is 0. Because this 0 has the largest probability. So find the D is find the EX, the mean. Just now I said I use 0 times the probability 5 per 15 plus 1 times 4 per 15 plus 2 times 3 per 15 plus 3 times 2 per 15 plus 4 times 1 per 15. So times all times all times all times all times all, so I will get 20 per 50, or simplify it as 4 per 3. So var 3. Var 3, just now I said the properties. Var 3, no x, so it will be 0. So f var the variance 3x minus 4. So before to find the variance 3x minus 4, so I need to find the ex square and var x first. X square is 0 square times 5 per 15 plus 1 squared times 4 per 15 plus 2 squared times 3 per 15 plus 3 squared times 2 per 15 plus 4 squared times 1 per 15. So I will get 10 per 3. Where x will be 10 per 3 minus the mean square, 4 per 3 squared, so I'll get 14 per 9. So where 3x minus 4, so we'll get 3 squared where x. So I will get 9 times 14 per 9, so I'll get 14. So if this 3x minus 4 is come out is in ax, how to solve? So just now I say the ex is 4 per 3. So it will be like 3ex minus e4 like this. So I will get 3 4 per 3 minus 4. 3 3 4 is 4 minus 4, so I will get 0. This is how for this mean, the expected value. So g is the var y, if where y equals to 3 minus 2x. Use back the value in this var x. So as you can see, this 2x, it got negative 2, so you include negative 2 inside. Don't ignore this negative. But if you square it, you will get positive 4. So that's why I say the variance will always be positive, like this. So 4 times 14 per 9, so I'll get 56 per 9. So h, I want to construct the cumulative distribution function. Okay. So I write it as like this. You can see that 0, 1, 2, 3, 4. So for the outcomes less than 0, so the cumulative will be 0. So for 0, usually I will write like this, from 0 to less than 1. Fx, so just 0 plus this 5 per 15, so I get 5 per 15. For 1 to less than 2, fx equals to 5 per 15 plus 4 per 15. This is the outcome of px equals to 1, 1, 1, sorry, 1, 9 per 15. So as you can see, you just add on the previous cumulative function with the new probability. So you will get 12 per 15, this 12 per 15 plus 2 per 15, so get 4 per 15. And last this 14 per 15 plus 1 per 15, so I'll get 15 per 15, so equal to 1. So I'll construct it like this. So want to find what? F3. So from this distribution function, F3, you see 3 here. So F3 will be 14 per 15. And J, I want to find the median. So median, as you can see, F0 will be 5 per 15. It is less than 1 per 2. But this F1, it will be 9 per 15, which is larger than the 0.5, which is the half the probability. So the value is included in this one. So the median will be 1. So last, you want to construct the graph of this probability and this cumulative. So for the probability, I use different color, so for easier to see. So for this 0, suppose it's a straight line, but yeah, sorry, my art. So 0 till 5 per 15, 4 per 15, 3 per 15, 2 per 15, 1 per 15. Straight line. But for this cumulative, you will be horizontal line. So you can see this 0, x smaller than 0, does not touch the 0, right? So 0, this the blank blank round shape. You can see this got touch this. which is got include, which is the colored round shape lah. I call like this. So the cumulative will be 0, this 5 per 15, 9 per 15, 12 per 15, 14 per 15, and 1. This is x larger and equal to 4, so it will be 1. Yeah, that is just now I said the discrete random variable can be presented in the way of function, table, and lastly, graph. Okay, here is the end of the discrete random variable, and I go to the continuous random variable, which is the last topic. So continuous random variable is a random variable that can assume any value contained in one or more intervals. So the example is salary of workers in a factory, time taken by workers to learn a job, amount of water consumed by a family in each month of a year, the height of students in a college. As these values can got the interval, like cannot count it like in detail, so it got the interval, so it's continuous. So for this, we call the probability density function. Distribution is the, the density. So continuous random variable are theoretical representative of continuous variables such as height, mass, or time. A continuous random variable is specified by its probability density function, which is written as fx function. This function is defined over the range negative infinity to positive infinity. So if the probability density function fx is larger than or equal to 0 for all x and is defined over the range equals to 1, then x is known as a continuous random variable. So if x is a continuous random variable with probability density function fx, then p is x with x more or equal to a and less than equal to b, so it will divide as integration. B is the upper boundary and a is the lower boundary. Notice that this integration is in fact the area enclosed by the curve y equals to fx, x-axis, the line x equal to a and x equal to b. As px equals to k equals to 0, where k is a constant, so then px, I highlight it. This sign, smaller or larger, this smaller and equal, they are all the same. So you no need to worry about the inequalities. So you just sub it as this form. Like this, it enclosed by the area. That means the function can be, if the question asks you to sketch a graph, so it can be drawn in a graph like this. Cumulative distribution function. So the probability of a cumulative distribution function is obtained by integration. So it is this fx. If x is a CRV with probability density function, fx for cover all this infinity, then the cumulative distribution function of x is given by x bounded by negative infinity fx dx. So notice that the link with the formula for the discrete random variables, px is replaced by fx, and this sigma thing will represent by this integral thing. So notes, fx is a fact given by the area under the curve y equals to fx from x equals to negative infinity up to x as indicated by the shaded region. So like this you can be negative infinity to this certain value. F negative infinity equals 0 and f infinity equals to 1. So px smaller than a, so will be also same as this smaller or equal to, so you need to no need to worry about the inequality. So same as fa. Just now I said this no need to worry about the inequality, so will be fb equals fb minus fa. So if the median is m, so p will be x smaller or equal to m, and ma fs dx equals to 0.5, and cumulative m is equal to 0.5. Since the cumulative distribution function is the integral of a probability distribution function, so it follows that the probability distribution function of a continuous random variable is the derivative of the cumulative distribution. That is, if you want to find the probability density function, you just differentiate this cumulative distribution function. Yeah. So the last is the expectation of x and variance. Expectation or expected value of a continuous random variable, the probability density function is the mean of x, is denoted by this mean of ex. So it's just same, but you just times this x inside the integration function. So if x is a CRV with probability density function, then the expectation or any function of gx given by you times in this gx inside. In particular, when gx equal to x squared, so you want to find the ex squared, so you need to times this x squared inside the integration function. The variance of a CRVX, yeah, just now I said, denoted by this. So the variance will be ex squared minus mean squared. So it's same, you need to find out the mean and this ex squared first in order to find the variance. The standard deviation also same as the discrete. You just square root the variance. So I also prepare a big question which includes all the things we learned. So let the probability density function of a continuous random variable x be defined as this. So show that you need to show many things up. So total up this question will allocated 30 marks. Yeah. So don't play as this chapter 9 in our batch here. In our batch will allocated the most marks as it will come out in part A of PSPA and part B. So in total it allocate 31 marks in our PSPM 2, which is it occupied the is the most important chapter lah, because it allocate the most mark. So A, show that C equals to 3. Show that this equals to 3. So it's simple, you just C negative C, which is bounded by C and negative C. So x squared 18 dx will be 1. So 1 per 18 C minus C, x squared dx equals to 1. So 1 per 18, x3 per 3. And C equals to 1. So 3 I can sub inside, so 18 times 3, 54. X3, C minus C equals to 1. So 1 per 54. C3, let me just show it. C3 minus this like they say cube, cube equals to 1. So C3 plus C cube plus C cube equals to 1. So C cube plus C cube equals to 2. C cube 2 times 1 per 54. So I'll get 1 per 27. C3 equals to 1. So C cube equals to 27 and C equals to 3. Find 0x2. So it will be bounded like 2. Let me rub. 20 x squared 18 dx. So as same, I just take away integrate below 1 per 54, which from just now here, So I just sub 2 and sub 0. So 8 minus 0, so 8 times 1 per 52, so I will get 4 per 27. C, find the median of x. So the median of x, I will write like this: x smaller equal to m, so equal to 0.5. So it bounded by m and the lowest boundary, -3. So, like this same, I integrate it and find this m cubed plus 27 equals 27. So m equals to 0. Sketch the graph. So to sketch the graph, so I need to find the lowest boundary. So f -3, I'll get 1 per 2. F0, the median, I'll get 0. And the upper boundary, I'll get 1 per 2. So my sketch will be this parabola shape. E, find the mean and variance. So the mean, as I said just now, same as just now, I integrate it, the upper boundary and lower boundary. So I just add this x inside times this x3. So it will be x power of 4 divided by 4. So 18 times 4, 72. So sub 3, -3. So 81 minus 81. So I will get 0. For the variance, before that, I need to find the ex squared. So I insert this x squared inside. So I get x4, x power of 4. So x power of 5 divided by 5. 18 times 5 will be 90. So 3 power of 5 minus -3 power of 5. So 243 plus 243. So I will get 27 over 5. So var(x) will be the ex squared minus mean square is 0. So just 27 over 5. So the f is find the cumulative distribution function. Hence, find p is same as b and c and same as b and c, but this time I need to use the way of the cumulative distribution function to do. I use different way, which is this way. So hence I find the cumulative distribution function first. Okay, for x smaller equal to -3, so fx equal to 0. There's nothing 3 between these 3, -3 and 3. So just 0 plus this x and lower boundary. So I will get the function as 3 plus 27. So just times this 1 per 54, 1 per 54 x cubed plus 1 per 2. For x larger than 3, so it will be 1. This sub it as 3, sub 3, and this no need. So sub 3, I will get 1 per 2 plus this upper x with upper boundary, it will be 0. So 1 per 2 plus 1 per 2 equals to 1. So I construct the cumulative distribution function. So P 0, so larger equal to 0, smaller equal to 2, F2 minus F0. So I just see this by using this function, by this 1 sub 2, sub with 2, 1 sub with 0. So I will also get 4 per 27. But this time I use the cumulative distribution function type method to solve it. Find the median. So the median Fm equal to 0.5. So I sub this m inside the function. So I also get 0.5 minus 0.50. So m will equal to 0 also. And last, find the probability density function. So I need to convert it back to this. For this, I use the differentiation. So for x smaller than negative 3, so I get 0, right? 0 cannot integrate, so will be 0. So for x larger than negative 3, smaller than 3, so I differentiate 1 per 54 x cubed plus 1 per 2. So differentiate, I'll get 1 over 18 x squared. For x larger or equal to 3, so 1 fx equal to 1. So differentiate 1 will be 0. So I convert it back. 1 per 18 x squared, negative x larger than negative 3, smaller than 3. And 0 for the numbers of the other number lah. Otherwise, so, which means the other number other than the value in between this negative 3 and 3. For example, 4 or 5 or negative 4, like this. So, okay, that's all. Here is the end of the chapter 9. So, see you in the next video, which is chapter 10. And bye.